This lecture is going to be on motions of the Earth, the seasons, and solstices and equinoxes. In order to talk about seasons, we need to understand some motions of the Earth. First definition here we have is a rotation. A rotation is when a body, such as a planet or a moon, is spinning on its axis. An axis is an imaginary line that runs through the center of the planet. The Earth then rotates around that imaginary line. You can think of it of a globe. If I have a globe and I spin the globe, that spinning motion is called the rotation. And the point in which it spins around is called the axis. Notice how the axis is not straight up and down as our light and shade line is. If we were to measure the light and shade line and the axis, and we measure that angle in between, we would come up with 23.5 degree angle. The reason why the Earth is on a 23.5 degree angle is because a Mars-shaped object flew into Earth long ago and smashed into Earth and knocked it on its axis. And that's actually how we got the moon. The moon is bits and pieces of the Earth that blew off from that impact and recollected to form the moon. A revolution is a body, such as a planet, completing a complete circle around an orbit. I put circle in parentheses because usually it's not an exact circle, it's more like an oval, and we call that an ellipse. The revolution of the Earth provides the Earth with 1 year. It takes the Earth 365.25 days to make one full rotation around the Sun. Notice how it's not even, it's not exactly 365 days. So because we have 1/4 of a day, every 4 years we have a leap year to compensate for that 0.25 of a day. If we do not have a leap year, eventually our summer would start to occur in the month of January. The Earth's revolutionary path is called an orbit. The Earth's orbit is elliptical, which again means like an oval shape. So note the oval shape of our orbital path. Now this picture is very exaggerated. It's not nearly this ovular in shape. It is more circular than this, but the diagrams often exaggerate this so you can see that we are closer to the Sun during some of the months and farther away from the Sun. The point in which we are closest to the Sun is called the perihelion. Helio is a root word meaning sun. Aphelion or aphelion is the point in the orbit where it is farthest away. Ap is a root word meaning far away, and helio means sun, so that's the point in which the Earth is farthest away from the Sun. Also take note that the tilt of our axis, you'll note, is tilted at a 23.5 degree angle. Let me ask you this. What causes our summers to be hot and our winters to be cold? The correct answer is the axial tilt, not the distance. So we are actually closer to the Sun during our wintertime, and we're farther away from the Sun during our summertime. Due to the collision that created the moon, the Earth is on a 23.5 degree tilt. This means that the North Pole points to the star named Polaris, which is our North Star. The axis always points in the same direction as the Earth revolves around the Sun. This means that the northern hemisphere is sometimes tilted towards the Sun and sometimes is tilted away from the Sun. This affects the concentration of our solar energy striking the Earth. The tilt also causes the total number of daylight hours to change. This is why we have longer daylight hours in the summertime and shorter daylight hours in the wintertime. This diagram is going to help explain why we have hot summers and cold winters. There are a few things to take a look at in order to explain this. First, let's take a look at our solar radiation coming in. Notice how our solar radiation is equally spread out from the Sun. However, if we take a look at the Earth's surface, Near the equator, our solar radiation covers a small surface area. But if we go up towards the poles, the same amount of radiation is spread out over a much larger section at our poles. So this is why our equator is hot, because they get more direct concentrated solar radiation, and our poles are cold because that radiation is much more spread out and less concentrated. Another thing to look at is the length of daylight hours. So the diagram over here represents our summertime. Let's say we live on the Tropic of Cancer. We don't, but we're fairly close to it. Tropic of Cancer is 23.5 degrees latitude. But take a look at the line. Notice how long that line is in the daylight hours versus in the winter time. If we take a look at that same line, that line is much shorter. So they get less daylight hours in the winter. They get more daylight hours in the summer because this path is much larger in the summer. Okay, another thing to look at is again the tilt of that axis, which is important. Notice how the tilt here is the same orientation as over here. The tilt does not change, but the Earth revolves around the sun. So in June, our tilt in the northern hemisphere is tilted towards the sun, giving us those more concentrated solar radiation and our longer daylight hours. In the wintertime, our tilt in the northern hemisphere is now tilted away from the sun. So now we're up here a little bit higher, so we get less concentrated radiation and we get fewer daylight hours. Let me ask you this. When we're having our winter, what's the southern hemisphere experiencing? In the southern hemisphere, their axis is tilted away from the sun. So they're going to have winter while we're having our summer. And if we look over here, in the northern hemisphere, our axis is tilted away from the sun, so this is our winter. In the southern hemisphere, the axis is tilted towards the sun, so they're having summer. So the seasons are opposite in the northern and southern hemisphere. Okay, let's take a look at this diagram and figure out the seasons. We're going to pay attention to the northern hemisphere since that's where we live. So take a look at diagram A. What season would diagram A be experiencing? Remember, take a look at the tilt of the axis. Is the tilt of the axis tilted towards or away from our sun? It is tilted away, so that means we are having winter. Next, let's take a look at B. If we don't know which way it's tilting, pay attention to this arrow here. If A is winter, what comes after winter? Spring. And what comes after spring for diagram C? Summer. Take a look at that axis. Let's double check it. That axis is tilted towards the sun, so that would make it summer. And then last, we have fall. When doing these diagrams, always start out with either winter or summer, and then follow the arrow around the circle. What season would the southern hemisphere have if the northern hemisphere is experiencing winter? If you guessed summer, you're correct. Next topic is solstices and equinoxes. Helio is a root word meaning sun, so the perihelion is the point at which the planet's orbit is closest to the sun. Remember, our orbit is not exactly circular, so that means we're closer to the sun at some point and farther away at other point. Aphelion. Helio again means sun. The point at which the planet's orbit is farthest away from the sun. What do you think ap means? Ap means away. So again, it's the farthest away from the sun. Solstice. This is the one day of the year which the sun reaches the highest or lowest point in the sky, and thus we have our longest daylight hours or our shortest daylight hours. Stis means to stop. So the sun's going to stop migrating to the north or south, turn around and go back. So it kind of stops moving on that day. What do you think sol means? We're talking about the sun, so that's another root word for the sun. So the sun stops moving north or south. Equinox. Equa means equal, so we're going to have 12 hours of daytime and 12 hours of nighttime during an equinox. During an equinox, the sun's going to be directly overhead at the equator, 0 degrees latitude. For the solstice, I mentioned it reaches the highest point. That means it's going to go farthest to the north latitude, which would be the maximum it's going to be overhead would be 23.5 degrees north and south of the equator, because that's the angle of our axial tilt. The summer solstice occurs on June 21st, so in the northern hemisphere. So on June 21st, we have the maximum amount of daylight hours, and the sun's going to be the highest in the sky on that day. During the summer solstice, the Earth is going to be at its aphelion, which means we are farther away from the sun during the summertime. I know that's counterintuitive, but we're actually farther away from the sun during our summertime. But in the southern hemisphere will be closest to the sun during the summertime. The winter solstice occurs on December 21st. This is where the sun's going to reach the lowest point in the sky for the northern hemisphere, because the sun's going to be directly overhead at 23.5 degrees south latitude. And the Earth is at its perihelion in the winter solstice. So we're actually closer to the sun during our winter time. Equinoxes occur on March 21st and September 21st. So on those 2 days, we have equal daytime and equal nighttime, 12 hours each, and the sun is directly overhead at the equator.